Welcome back. We're going to start talking about Chapter 6 today, which is where we look at the idea of designing software using the methods that we can write in processing. So what we'll look at first is the motivation and need for a rational design process as our software gets more complicated. And that's what this first video will be all about. Later videos then for Chapter 6 will talk about top-down design. We'll talk about how to write non-built-in methods, so that would be methods like that aren't the draw method or setup method, for instance. We'll talk about scope. Again, that's something that we've mentioned tangentially in previous chapters. We'll go into that in more detail here. And then we'll also look at an implementation strategy on how we're going to write the order that we write our methods in when we have a lot of them to write. All of this, after the motivation and need part, will be done in the context of the chapter example, which is that Solopong application. So, let's talk about motivation. Pre-1970, software was small enough that a bunch of really smart people could get together and write the software without really having a grand unifying methodology or plan for how to do it. So for instance, let's talk about Apollo, the Apollo program, one of the greatest achievements of humankind, landing people on the surface of the moon. How much code do you think was required to do that? We're talking about the systems that guided the spacecraft from Earth to the moon, that were allowed the lander to land on the moon safely. And obviously there was lots of manual intervention by the astronauts, but clearly they were computerized as well. So how much code was there? Well, it turns out there was a roughly 7,500 lines of code in that whole project on board the spacecraft, which is not a lot. It may sound like a lot to you right now, but everything that we've been doing has been very tiny. So 7,500 lines is actually a very, very small piece of code. It's a very small piece of software. Okay? So around that time, projects began to fail. They began to arrive late. They were over budget. They were error-ridden, and a lot of them were never finished at all. So as we wanted to do more and more with computers and our ambitions for using them got larger, around 1970, that software started to be very difficult. We couldn't create it. We couldn't make it happen on time and on budget and in a reliable manner. Now, obviously, you may wonder whether we're doing that now, but it's nothing compared to what it was back in 1970. So why is that? What do you think is the basic reason for the problems that started to occur back then? Well, you may have gotten the point already. The idea is size. Modern software is a lot like this quote from Douglas Adams in The Hitchhiker's Guide to the Galaxy. You really can't understand how huge modern software is, especially at this point since we've just been writing very tiny programs. So let's look at some other examples. Donkey Kong, classic 1981 arcade game. How many lines of code do you think Donkey Kong had? Well, 25,000. That seems like a big project, doesn't it? But it's nothing compared to what we've got coming up. Okay, so let's move on. What about processing? And in this case, what we're talking about is just the IDE, the development environment that we enter and execute our programs in. How big do we think that is? Well, it's an open source project, which means we can go out, we can download the source code, and we can run it and compile it ourselves if we so choose. We could also count all the lines of code. And so it's in the neighborhood of 200,000 lines of code just for that IDE. And that doesn't touch the underlying Java programming language, which of course in and of itself has to be written in a language. And there's probably millions of lines of code in Java. Okay? Modern airliner. So the 777 is an airliner that has fly-by-wire flight controls, which means computers control the movements of the control surfaces according to the pilot's inputs. So that has to be done with computer software. So how many lines of code do you think the 777 has? 2 million, roughly. Okay, so now we're getting truly sizable, especially compared to the 100 lines or so of code that we've been writing so far. OpenOffice. So this is a little more mundane than the flight control software of an aircraft. But this is the open source Office productivity suite that you can get on the internet. 9 million lines of code. What about Windows 7? How big do you think that is? Well, it turns out that it's probably in the neighborhood of 50 million lines of code that went into Windows 7. So that's really huge. Okay? So size is certainly an issue, but the complexity of it is also a problem. So let's kind of put that in context. Back in 1956, psychologist George Miller came up with this idea of chunking. He argued that humans can only process 7 plus or minus 2 chunks or elements in their short-term memory. Okay, so really that's the number of things that we can focus on at a time. So 5 to 9, somewhere in that area. Well, you may notice that that's significantly less than 50 million. Okay? So we just don't have the mental capacity to truly understand software, particularly large modern software. Okay? Modern software is unknowable in its entirety. No one person can know everything there is to know about Windows 7. It just doesn't exist. And that should really be scary, because you're putting your life on the line in a very real sense with the Boeing 777 or other fly-by-wire aircraft. You're putting your life on the line with their software. And are you sure that it's written right? So, in order for modern software projects to work, what we have to do is use some methodology that makes it all understandable. And what we're going to do is learn how to chunk it up into pieces that can be grasped by us. And we're going to do that in an old way. And in fact, this is sort of the original way of doing things from way back in the day when we first started to have those problems in the 1970s. So this is an early but still viable approach, and it's a good place to start. And we're going to have 2 strategies: top-down design and structured programming. Okay? Top-down design means we're going to decompose problems into subproblems and then repeat that decomposition until each one is graspable. And that is a concept that we've looked at before and mentioned in several other instances of problem solving in the text. Structured programming means we're going to implement that program then as a hierarchy of methods. So we'll have our draw and we'll have our setup, but then those methods we'll call sub-methods to do other things related to their tasks. Okay? So that's really the motivation that we have for wanting to do things a little bit differently. And now we know that the 2 pieces we're going to look at in this chapter are top-down design and structured programming. So in the next video, we'll start to think about those things.